All right, guys, welcome back to the third part of today's lecture. I just want to introduce the idea of structures. Real quick, structure is just going to be a composite data type. This is going to be something where we maybe have more than one piece of data that we want to group together. They may have different types. And so my example here is just going to be a structure that stores data about students. In Java, we would have called this a class. C++ would also use class or struct. In C++, they pretty much mean the same thing. But in C, this is just going to be a collection of data. So, put me back on this screen. And in order to declare a struct, a syntax is very similar to that you'd see in C++ or Java. The keyword is struct. Then I need to give it the name of my struct, whatever I'm going to call it. In this case, I'm going to call it student. My convention is to use capital letters for all structs. I use uppercase for functions, with the underscore, and I use lowercase for all variable names. I don't know if you guys have caught on to that or not, but that's just what I do. Whatever you guys want to do in your code is fine, as long as you're consistent. Anyway, then we'll need the curly braces, open and close, followed by a semicolon. And then inside we just put all of the data we're going to be storing in this struct. So in this case, my student has a name, so I have a character array, or a pointer to a character. I'm going to call that name. And I have an ID, which is going to be an int. So then once I've declared this, and I'll show you how to do this in the code in just a second, I can create a variable. So basically this is creating a brand new type, just like int and double and float are types of data. This is just going to be another type of data that I've named student. And so I can create more variables using this type. So I've created a new type. Here I'm creating a variable called s1 of type struct student. And then to access the members of this struct, I'm just going to use the dot notation. So s1.name, I'm going to give it my name, Mike, and s1.id, I'm going to give it my ID number, 1, 2, 3, 4, 5, 6. Please don't abuse that if you ever run into somewhere where you can access my personal information with my ID number. I appreciate that greatly. Okay, and then let's take a look at what's going on in memory. So somewhere in memory, I've created reserve some space for S1. C knows how big this is. I've got a pointer to a character, that's going to be 4 bytes, and an int, that's going to be another 4 bytes. This will take up 8 bytes total. After I've already done this variable assignment, if I've given it Mike, somewhere in memory, Mike with a /0 as a string will be available. This takes up 1, 2, 3, 4, 5 bytes, and is at address 0x3000. So this is what's going to be stored in my character pointer. Okay, and then I've also got another piece of data, this integer, 1, 2, 3, 4, 5, 6. I'm just storing that in the next memory slot there. All right, now I'm going to jump back over into a CSL machine, and I'm just going to go through and create a file, structures.c, to demo this exact concept. But I changed focus when I turned on the recording. Okay, so first thing, I'm going to be printing out my structure. So be including standard.io.h. We'll need int, a main function. Flag doesn't seem to be too bad, so I think this will work. I'm going to create a struct up here before main, so it's a global. So we'll have struct student. I need those curly braces. And the struct is going to be terminated by a semicolon. It's a definition. And then inside of this, I'll have char star name and, oops, got semicolon, int ID. There we go. That's all there is to it. And now down here, once I have my, inside my main function, I can create data of that type. Struct student s1. And then exactly like before, I can say s1.name equals Mike, and s1.id equals 12056. And then let's go ahead and print this out. So I'm going to write a function that prints student. So we'll just do that right here. We'll give it s1 to be printed out. So right now that's not available, so we'll need to go up and define that. So let's do that right here. So it's not going to return anything. Print student. You know, I really like capital letters here. And here. There we go. Okay, I'm happy now. So I'm going to print out student. So this will require that I give it a struct student. I'm just going to call it s inside of this function. And I'm going to go ahead and define it right here, because this is only really going to be one line. I'm going to printf, and then let's see, we'll give it a string. There we go. We'll tab over, and then we'll print out the ID. So that's an integer. So then we'll take s dot name and s dot ID. There we go. Pretty straightforward. Let's just head out, compile this, and see where all the mistakes are that I made. Ooh, I forgot the return. I can see that already. Return 0. You guys spot anything else I did wrong? Right, quit. So GCC, and I called this structures. I need the -o. I'm not good at remembering that one. So -o, and then structures.c.m32, and on all the warnings, we'll get those things fixed. Let's see what we got. Oh, check that out. It compiled on the first try. Okay, so we'll just go ahead and make sure we have a structures here. There it is, structures. When we run this, yep, there it is. It prints out my name and my ID number. I'm going to go ahead and put a return in, because that's going to be something that will really bother me. All right, hold on. There we go. Right up here, my print statement after D. There we go. Now it's going to look good. Perfect. All right, so next up, I wanted to introduce the idea of type defs. So when I look at this code, everywhere I use a student, I've got a typed struct student. Here I've got a typed struct student. One of the things I can do is create an alias for this by using a type def. So type def struct student. I'm going to just rename this to student. I think this works. I think I can reuse the same name. Let me just compile this and see if that works. Yeah, no problem. So then let's go back. And now that will let me say that this piece right here, right there, struct student, I've decided to rename this to just be student. Okay. This type def is actually really commonly used. People tend to overuse it. And the number one way that I've used it in the past, because I do a lot of math, is to rename float and double to T. And that lets me change the number system I'm using for all of my math to either floats or doubles. And math with floats can be faster, but you lose accuracy. So if you've got code that runs very slowly, switching to floats might increase the speed of that computation, and you can test things to see that they work. And then when you need the high precision, you can go back and switch that out for double. Okay, I'm not doing any math here. I'm going to remove that, but that's just an idea to demonstrate this. All right, so this is one way to do it. And now I should be able to remove delete word. And down here, I'm creating one, so I can delete the word. There we go, that looks good. I'm just going to save and quit and make sure this actually works. So we'll compile that and run it. No problem, exactly the same way. All right, now even one more shortcut. So let me pull up the editor again. I can actually put my type def right up here. And then this is the type I just created from here to here. And so I've basically taken this part right here, and that got replaced right here, copied and pasted more or less. You can think about it like this. So I can just write one giant composite statement, call it student right there. Now I'll get rid of this line. And save this, and I just want to make sure this works. no problem. Okay, and then even one more shortcut. I'm pretty sure this works, if I remember right. I think, because I'm creating a struct and I'm using a type def, I'm pretty sure I don't even need the name right there. This will create an anonymous struct and rename it to student. Let me just see if this works too. Compile and run. That also works. Okay, so stop that mic. Bring this back up. So there we go. This is the shortest, most concise way to make a new type of data with whatever name I like. I'll go ahead and I'll put all three of those in, and I'll comment out the sort of progressively more challenging ones. I'll just leave the basic one here uncommented. But for now, while I'm doing the video, I'm not going to waste your time. I'll go ahead and put those in. So when you download this file and follow along, they'll all three be there. Okay, the next thing I want to do is actually create a pointer to a student. So this is also totally possible. So I can create a pointer to a student. I'm just going to call that PS for right now. And I can give my pointer the address of S1, which is me. And then, so right now, the first print statement will be printing out S1. The second print statement will print out PS using the pointer. But I can't just do that because the pointer is just a memory address. I need to add the dereference operator, the star there. Okay, so that will now take whatever is in the contents of S1 and paste it up here into that data structure. So let me just demonstrate that that works. There we go. I printed Mike twice. The first line here is with my regular data structure S1, and the second line is using a pointer to access that data structure. All right, messed that up again. Sorry about the chiming. We'll head back to Vim. Okay, next I want to highlight one kind of important difference between using pointers to access things and using just the regular data to access. So up here in lines 18 and 19, I was using S1 as the name of my student and the access operator, .name or .id. So if I want to make changes with the pointer, so I've got PS declared right there to be the address of S1. I can dereference this and then assign the name a new name called Dr. D, and let's just see. This should give me an error, but I want to take a look at what the error really says. Okay, so this is actually really useful. Error PS is a pointer. Did I mean to use dash the arrow instead of the dot? And indeed I did. That's what I need to do. But let me go back and explain why. Where's the Vim line? There it is. Okay. So what this is, I've got two operators that are being used in the same piece right here. I've got the star, which is the dereference operator, and the dot, which is the structure access or member access operator. It turns out that the member access operator is like in category 1 for the top of the list for precedence. So that's going to say that this is going to happen first. It's going to go to PS, which is a pointer, and try and access a member data. So this is just 4 bytes, it's a memory address. It doesn't have a .name. So what I need to do instead is something that looks like this. Put some parentheses around this so that the pointer is dereferenced first. So it's going to follow that address and get to S1, and then I can access the name. All right, let me move that. This is kind of awkward to remember to type. I usually start myself, start writing out PS and then dot, and then I need to go back and put parentheses in. So they're providing, C provides shorthand. Whoops, typo. So that I don't have to do that. Instead, I can just use the arrow, which is shorthand for parentheses star PS parentheses dot name. And we'll say that is equal to Dr. D. And I totally can't type, so we'll get those fixed. An extra one of those. All right, let me see if this works or if I have any typos. Nope, that looks good. So now I've, let's see, where did I run it last? I've got my name as Mike, my ID, and then I've upgraded my name to Dr. D with ID still. All right, the next thing I want to do is go back. Let me take a look at the code real quick. And notice that everything in C is passed by value anytime I call a function. So what I've done here, I actually have a very small structure. It only has two things, a pointer to a character array and an integer, so it's only 8 bytes. But I just copied that entire thing up here in my function call. So right here I copied it again right there. This is undesirable, and good practice is to never pass a structure. Instead, what we want to do is pass a pointer to a structure. So we're just passing 4 bytes. We can make it a constant pointer if we want to guarantee that we don't change it. And if we really do need a copy, we can make the copy inside. So here's the idea. I'm going to change this function right here. So let me just make a copy of this. We'll paste that right there. Give ourselves some blank lines. We'll keep that one. We'll print student, and then we'll rename this to pointer print student. I hope that's clear what we're really doing. And then to upgrade this, I need to make this actually a pointer. So student is my type. So just like I had an int star, this is a type, just like int is a type. When I've got the star, this is declaring a pointer. When I'm using it down here like this was the dereference operator right there in star PS at the bottom. Okay, so the next thing I need to do is, because this is now a pointer, I can't access this with s.name anymore. I need to go back and change this to s_arrow, and this one also to s_arrow ID, just because I'm using a pointer now and I want to actually follow the pointer with the dereference and the access operator. So that's the arrow when they combine together like that. Okay, so the next thing I'm going to do down at the bottom, I'm just going to leave all that stuff up here. Whoops, got an extra character there. Oh, I'm making a butchery of this. There we go. Okay, so I'm going to pointer print. Pointer print student. And then I'm just going to give it, we'll do the pointer version first, PS. And I don't need the star or anything because it's already a pointer. So let me just make sure this works. Compile it. Oh, I made a mistake. Oh, I've got a typo right there, SI. So what line was that in? Right there. There we go. Okay. And we'll just run this. And now I've printed Mike using the regular print student, Dr. D with the print student. I changed it using a pointer. And then this should be the same thing getting printed, but using the pointer print student version. Let me go back up and just make one real quick change. Before I do the pointer print student, just so I can see that it's actually different, I'm going to insert, and we'll change the name, s1.name equals, we'll change it to Michael, and we'll print it out again, and then we'll do the same thing again. s1.name equals, change it one more time. That looks good. And then we can pointer print student. And I'm going to do this with S1 instead this time. I can't give it directly S1 because I need the actual address, because the pointer here, student pointer S, needs to be assigned the address of this. So I'm going to just put the ampersand in right there. Verify that looks pretty good. And run this. So compile, make sure that I didn't make any more typos. And then run structures. Yep, so now I have the Mike version. That's with the print student. Dr. D printing the dereferenced pointer to the student. The Michael version, this was the pointer version with the pointer print student. And Mike Dosher was the regular student printed with the address assigned to a pointer. Alright guys, that'll do it for this video. I just want to go back and highlight what I've done here. I put in all three versions that I sort of developed as we went through this. The first one just clears student struct with the name and the ID, and then I'm using the type def, so then struct student here is in the name of my new type, and I'm just going to use the word student for that type. I can use anything I want here. It doesn't have to be student. Okay, that's version 1. All of these are enclosed in comment switches, so I can just remove that first slash, and that will comment out that entire block. And then I can go down here, and I can insert another slash, and that will comment out the /* comment block. And now I have the second version here. This is the one where the type def includes the definition of the struct. So this whole thing is actually replacing so that highlighted text replaces this text right there. Just copy and paste it in. And then I'm giving the student right here is the equivalent to that piece right there. I've just done it all in one line. Okay? And then let me comment that part back out. We'll insert a slash right here. So now this slash is a comment, and the rest of this line from the star on is comment. And the closing comment here for the comment switch is also commented out by those. So now this text is turned on. The anonymous struct just means when I create struct, if I'm doing it in this type def form, I don't actually need to give it a name right there between struct and that curly brace. So I can just leave that out. I don't ever need to assign it a name. The compiler doesn't need to know. It just needs to know that I'm going to be using the word student for this entire object right there. All right, one final thing. I've gone back and I put in the struct student right here in case you comment out the type def and you still want to see it working. But I left it in right here. This is the type def student. And this is the original. The original will always work. And the type def just gives us one more way to talk about this structure. An alias is what it's called. And the rest of the code I left alone. It's all just the same. So go ahead and download this. And as you go through the video, you can play with it, make some changes, do some experiments. I highly encourage that.